Hello everyone, my name is Hesam, and in this video I'm going to go over the cruise performance and how to calculate the cruise performance based on this packet. We have been told to calculate these performance figures to level off at 7,500 feet based on the aircraft configuration, and we're going to configure our aircraft by 70% of our power. So we're not going to go full power, but we are going to be 70%. So we're going to explain what does it mean in a few minutes. We go directly to the cruise performance. So in cruise performance, we're interested to find out what is our aircraft going to perform in that altitude. So we are going to fly at 7,500 feet, and we have given this chart. This chart is going to help us with our pressure altitude. If we know our pressure altitude, we can directly go to our BHP and find the percentage of the power that we are going to use and read the true air speed, which is here. KTAS is the true air speed, and we're going to find our gallon per hour, which is our fuel burn number. So I'm going to give you an example first, and then we go to go over this example that we have here. So if we had to climb to 12,000 and the temperature was standard, so we could easily go here and look at these figures right here, which is we are interested at 70%. Let's look at this. This is easier. So 10,000 feet and 70%, it gives us roughly about 122 knots and 8.0 gallons of fuel. However, for this flight, it's not the case. So our temperature is not a standard, and we're going to figure out actually if we're going to use which column we're going to use. We have this column tells us the values of 20 degrees below standard temperature. This column, the whole column, going to tell us about standard temperature, the values on standard temperature, and this column, it's 20 degrees above a standard temperature. So we have a broad span between those categories. So first of all, we need to know if which column we're going to use for this example. So in order to do that, we need our Windsoloft, because we know that the temperatures and the wind's directions changes as we climb. So we're gonna go over the Windsoloft right here. We copied it from the aviationweather.gov. So and if we found the closest station to us, to John Wayne, is Ontario, the reporting station in Ontario. And these are the values for 3,000 feet. These are the 6,000 feet, 9,000, and so on. So we're gonna find out what is the actual temperature at 7,500. How we do it? I can show an easy way to do that. So you copy down these numbers. So you remember 6,000 is 12 degrees Celsius and 9,000 is 7 degree, and you come back to the last table that you have, and you have this table right here that is printed for you. So you have standard temperature values right here, and you can write the current or actual temperature values right here next to it and compare it and easily find your numbers. So we know that at sea level temperature is 15 degrees. So each 1,000 we lose about 2 degrees roughly in temperature. And at 7,500, the standard temperature is 0 degree. And if we look at this chart right here, our METAR says that today at sea level is 19, so 500 feet is going to be 20 degrees, and our temperature at 7,500 feet is going to be 9 degrees Celsius based on the Windsoloft information. So we see that, okay, we have only 9 degrees, we are 9 degrees above standard. So now that we know that, we can easily find our values. So we know that this is 20 degrees above a standard, and this is a standard. So 9 degrees is almost half the way between these two columns. So not a standard, not 20 above, but at between them. So I'm going to write those numbers for sake of easiness right here. I'm going to write the standard numbers right here. We are interested in true airspeed and gallon per hour. So I'm going to copy down these numbers from this chart right here and bring it to here. But we're going to make sure that we are only interested in 70% of power. We are not interested in 58 or 75 or 47. These are the power settings. So we are being told to calculate the 70%. Here in this case, we didn't have 70%, so we just interpolated between these two numbers to create the 70%. So between these two numbers is 118, and between these two numbers is 8 gallons. So this is the values for 70%. So we're going to bring it down right here so I can explain to you what happens. So we know that at 6,000 it's 118 knots and 8 gallons, and we know that the 8,000 it's 120 and 8 gallons. So between these two it's going to be 7,000 feet. At 7,000 feet the value is going to be between these two, so 118 and 120 is going to be 119, and between these two there's no change of gallon per hour, no fuel change, so we're going to copy that number. And between 7,000 and 8,000 now we can find 7,500. The true airspeed going to be between 119 and 120 it's 19.5, and between 8 gallons and 8 gallons no change, so we write it down here. Also you can use other methods like multiply it by 1/4. Any math that you can use. This is just easier for me, so I just write it down very quickly. And why I do it, because I'm not a very good at math, so that's the way I do it. And I write down the numbers for 20 degrees. Again, the same system. So we copy down the numbers. We find the values for 7,500. And finally, we find interplay between these two. How we can do it? So we know that between 119 and 118 is between 120 and 118 is 119, because we're interested in 10 degrees, almost 9 degrees above standard. These are the values. So the final answer for 7,500, the true airspeed that it will give us today, it's 120.5 knots of true airspeed, and our gallon per hour usage of fuel, it's 7.95. Thank you so much for watching.